All right, let's see. Okay, so I believe the last one we left off. So we did list length. We did, okay,
Yeah,
list contains. Nice. Okay, so I see that you have some commentary.
yeah, I was trying to like explain it to you and
Okay,
myself.
nice. Uh, do you use the pirate documentation for this?
Uh, yes, I
Oh,
Googled
cool.
it.
Very good.
Yeah.
Okay. Yeah, that's a skill I didn't really cover with you, so I'm glad you figured that out.
Okay, yeah, I
Uh,
have like experience with like Python. I did
very
like
good. Okay, so 9326 to 9330, right? There's actually an easier way to write this. Whenever you have an if expression, if statement or if expression, yeah, sorry, an if expression. So this is an if expression, line 326 to line 330.
yeah,
Um, actually, wait, let me explain that first. I'm going to go to the bottom of the file. I'm going to do something. What will this produce?
like uh oh, 2, yes, because I what I don't know what is the like default value.
Well, maybe it's the indentations that's messing you up. What if I do this? Okay, looks like crap, but hope you get the idea.
Yeah, I understand it, but
So if true, what happens when it's
yeah,
true? Which branch do we go to?
like else, yeah,
Wait, no, true is the first one. So it should be one.
yeah, yeah.
All
So
right.
we go to 1, yeah,
Okay, so X gets one, right?
yeah.
All right, let's run it. Do you see one?
Okay,
Okay, notice something. This if is like to the right-hand side of the equal sign, right?
yeah,
So if here is an expression, it can give you an answer. Okay.
okay.
In C++, this is not the case. Oh wait, in C++, okay, in C++ you have to do this.
I know this, yeah.
You've seen this
Yeah.
before?
Yeah,
Okay,
yeah,
C++ you
yeah.
gotta do
I do this
this.
like a lot of times. Yeah,
Okay,
because
so
it's like shorter, yeah.
this language, if is an expression, so you don't have to do the question mark colon, you have to just write if else n. But
Okay.
all this is to say is that if is an expression in this language. In other languages, if is a statement, it doesn't produce an answer.
Oh, okay.
Yeah, so that's the distinction.
Okay.
We're going to revisit the idea of statements versus expression, but for now, just think that expression
Mm,
gives answers, statements don't give
yeah.
answers. Statements just do things.
So it's like how to write the expression.
So double S-I-O-N. Yeah. So it's like
Okay.
express. So an expression
Okay.
is like you trying to express something to the language. That's why
It
we call it
makes
an
sense,
expression.
yeah.
Okay. So anyway, whenever you have an if expression that produces a Boolean, you could usually use a Boolean operator here. Could we use a Boolean operator for line 326 to 330?
Uh like what?
What are
I
the Boolean
suppose so.
operators?
Like true and false, yeah.
No, those are Boolean values.
Values,
Op operators are like
operators.
math operators are like plus, minus, times, divide. But what are operators for
Oh,
Booleans?
like uh equals and does not equal, yeah.
Oh, yeah. How about other Boolean operators? Like C++, plus plus, when
That
you want to do things to Booleans, what kind of operations do you use?
what I don't do what?
Okay, let me give
Like
an example. Like C++, have
okay,
you seen
okay.
this? like A,
Uh,
L, and B.
yeah, okay, okay, okay.
So this one is in this language we do A and B.
So like in
And
Python, yeah? Okay.
yeah, I think Python is also like this. And then if it's
Yeah.
A or B in this language, A or B.
Or okay.
So not
Okay.
A is look okay, this is the most distinct. Not A is like this, you write not and then you have to put in parentheses.
Okay.
So these are the three Boolean operators in this language. Could we use one of these for line 326 to 329?
Yeah, I don't get it. Sorry.
No, it's okay. Okay. Okay, I'll give you the answer once, but hopefully remember it in the future. Okay,
Okay.
so whenever you see this pattern, if true, do nothing and just say true. Otherwise, do more work.
Okay.
Whenever you see this pattern, it can actually be reduced to this. So take the condition of the first one, or and then the second one, the second expression, like this. So these two, line 326 and 327 to 331, are equivalent. Okay.
Oh, okay, okay,
So if none equals target is true, so we call this short circuiting. When the first thing is true, the second thing doesn't run. So if none double equals target is true, list contains does not run.
okay.
So I'm going to leave a note here, short circuiting, where first, okay, I'll say left-hand side is true, right-hand side does not run. Okay.
Okay.
So I'm going to delete the long if. So um, do you really need to know this? Like um, you can always write it a long way, but I think it's a good habit to have to express it cleanly. So
Okay.
if we run it now, let's see. Oh, let's delete the extra stuff. Oh, okay. So I just ran it and it says that it doesn't understand order of operations. In C++, this would
Mm,
have worked, but here we need to put parentheses around this
okay.
because there's no order precedence here.
Yeah.
Okay, so same thing, right? See, the test still passed. And this is also why we have tests, so that we can change things, run it, and see that things still work as intended. Okay. I'm going to go to line 341. I'm going to explain another idea of short circuiting. Let's say like, so I'm on line 341 right now. False and list contains. For n, if the first thing is false, the second thing does not run. Okay?
Yeah, it makes sense, yeah.
Okay,
Okay.
short circuiting. Yeah, so same thing for n, but the first thing is false. Right, because if one of them false, it's entirely false. It doesn't make sense
Yeah,
to run
yeah.
it. Most languages have this. This language has it as well. Okay, let's move on. List average. Oh, okay, very good. You did list sum and list length. Oh, okay, very good.
Yeah.
There are multiple ways of solving this. This is one of them, and this is the intended solution.
Okay.
Okay, let's see what you
Like
wrote here.
I was trying to do it like from zero, but when I thought about it when I was like helping my parents, I
Okay.
I came up with a solution.
What, how do you pronounce the Polish vegetable soup?
Lecho.
Lecture. I see. Okay.
Lecho. Yeah,
That's
yeah.
interesting. Like while you're doing, there's actually something very common in computer science. Like when you're solving a problem and you go do something, a solution will come to your brain.
Yeah. It's
Yeah.
like magic, yeah.
Okay. So this is one of the solutions. When you say like the first comment you have, we need to have a variable to keep track of how many numbers we have. That is actually the second solution, and we'll revisit this in the future.
Oh, okay.
But it uses a different technique that we'll cover. So keep that in mind. We'll revisit this problem. Uh, but yeah, the definition of average is the sum of the things divided by its length. So you figure that out. Notice here we use helper functions. Like this function calls another function that has to do with the list, right?
Yeah,
And those two helper functions are themselves recursive.
yeah.
So I'll leave a
The
note for you.
end.
So I'm going to leave a note in line 362.
Okay.
helper functions are also called we also call them auxiliary functions. You can also say helper functions. They can also be recursive. Um, this is the idea of function composition. This is the idea of function composition. So usually I teach this idea explicitly to students, but this one I'll let you figure out on your own.
Okay.
So in mathematics, have you seen something like this before? Like,
No, I haven't. I haven't yet.
or like, actually, I should like, how far are you in mathematics? Do you do like algebra and whatnot?
Yeah, like uh, I'm going to learn like quadratic functions. Yeah.
Okay, okay. So this is about your level. Okay. So anyway, in mathematics, right, when we define a function, so I'm sure maybe you have seen this like f of x equals one, or f of x equals
Yeah, of
x.
course. Yeah, yeah, yeah.
So we can also do this actually. F of x equals g of x plus 1. So
Yeah,
if we do,
it makes sense. Yeah. So it's
yeah,
like it would be like easier to write. Yeah.
exactly. The idea here is that when you define a function, that function can use another function. Uh,
Okay. Yeah.
in programming, we call this function composition, to like composing functions, like putting functions together. So this is a very important idea in programming, and you will use this a lot.
Okay.
In fact, remember the last time we introduced the idea of templates? You remember the ball and vector 2D example?
Yeah.
When we
Yeah.
wanted to operate on the ball, we delegated, we like used another function that adds two vectors together.
Yeah.
The adding two
That
vectors
is
together is an auxiliary function to the move
okay.
ball function. Yeah. Okay, so you've seen that before, but the twist here is that the auxiliary function can be recursive. Okay,
Okay.
but yeah, all
That
right.
is like unnecessary hard word. Can you just
Uh,
like
oh, helper function.
uh
Oh yeah, yeah, yeah.
yeah,
I'll delete the auxiliary. Okay, helper functions.
it's like the synonyms, yeah?
Yeah,
Like helper and auxiliary. I
yeah,
don't even know how to say that.
auxiliary. Yeah, I don't know why people say auxiliary actually, but if you work in industry, which I guess is quite far from
Okay.
you, but if you do, people might say that word. But it's okay. You don't.
Okay.
For now, you don't have to know. You just have to know helper functions. People say that too. Don't worry.
Okay.
Okay, let's see what you have here. We have to work on two lists to take something from one and put it in the other, but we need to return one list, maybe a nested function. Oh, when you say nested function, you mean like function
Like
composition?
helper. Yeah, yeah, yeah. Like
Okay.
helper function, yeah.
Yeah, nested functions, the correct usage as well. People also say nested functions. Usually when you have
Okay.
a nested data definition leads to a nested function.
Okay.
In this case, yeah. Yeah, okay, yeah, I'll leave it at that. Okay, two hands left with our current list, and right, that is empty. One, two, three, empty, empty, two, three, one. Yeah. Yeah, yeah. So this is one of the solutions. This is the intended solution for what we currently learn. Oh, I noticed you define the function move L to R inside list reverse.
Yeah, yeah, we could do it like we could do
Yeah.
this like outside of it, but
Okay. This is pretty cool that you figured this out. It's we
yeah,
call
I
this a
thought
local
like
function.
okay,
Yeah, cool.
we don't have access to it like outside of this function, yeah?
Yes. So we'll
Okay.
cover this more. I don't know if we'll cover this more explicitly, but I guess now that we're here, I'll talk about it. Um, yeah, this is one good use case of it. When you have a function that's very specific to the function you're writing, you just put it inside. Uh, there
Yeah,
is
it
pros
makes
and
sense, yeah.
cons. The con is that your function looks kind of big. I don't know if you noticed, like this list reverse is very
Yeah,
simple. It's moved L to R, but it looks kind of big. The benefit is that if people don't need to use the function inside, then they don't need it. So let's just put it inside. Um, Another benefit is the idea of scope. We didn't talk about scope, but for example, okay, this is just a sample idea. I'm gonna reverse this later, but on line 381, I'm gonna change right to num list. Okay, just
okay.
to show you the idea that this inner function move L to R can actually refer to variables outs in the same scope, like num list.
Okay.
Okay, have you heard the word scope before? SCOPE?
Yeah, yeah.
Okay, so you know what I'm talking about. Okay, good. So that's another reason why one might use a local function is to be able to access variables from the outer function.
Okay.
Yeah, so this is one of the this actually this is not quite this is the same idea as the intended solution, but it can be done differently.
Oh,
Um,
okay.
so
Like I
I'll
don't know
talk
the
about
intended solution, so
I think I'll go over that with you also.
okay.
I'll first explain why this isn't the intended solution and what techniques you're using here. So notice the right-hand side, you have a second variable that you're adding things to it.
Yeah.
So we call this an accumulator. Um,
Okay.
it- so there's a whole recipe for accumulators and how to work with them. In our case, I don't want to cover that yet. I want to save that for the future. The accumulator here is actually the one of the better solutions, but I want to go over the solution that is more obvious. Because to deal with accumulators, you have more steps to think about. You seem like you figured it out, but I want to save that. So I'm gonna give you an alternate solution. So I'm gonna comment out what you wrote in the future, and we'll revisit this.
Yeah, okay.
So first, I'm gonna take the list template. Let me scroll up. Oh, it's quite far up now. We've done a lot. I found it.
Yeah, I like have written a lot of comments, yeah.
Very good. Okay, so I've pasted in the template. So what happens when the list is empty? When you're trying to reverse an empty list, it looks like we get back an empty list. Next, okay, num list, num and rest, and then we have num list template rest. Okay, so what do we do with the rest of the list? Usually what you want to do is you want to reverse the rest of the list. Okay. Okay,
Okay.
we've reversed the end of the list, but we can't just put the number on top of it, right?
Right,
Where does the
yeah.
number have to? So we have a number and a reverse list. Where does the reverse list go?
Like before the number, yeah.
Yeah, the number here. Before list reverse rest, there's a number. What do we do with the number?
Like put it in some other num list, yeah.
What is that other num list? So let's work through an example. Let's say we have 3, 2, 1, right?
Okay, okay, yeah, right.
This example you have actually. So we split this into 3 and 2, 1, right? We have num and
Yeah.
rest. And now we have 3, and then we reverse the rest, so the rest is like this. What do we do with the 3?
Mm, so we put it in the end.
At the end, yes. So we have to turn
At
it
the
into
end.
this. But it's going to be, no, it doesn't matter what the list and numbers are, right? It's always going to be the end. So we need to add the number to the end. And as I don't think there's a function in the list library to do this, so I think we have to create our own.
Okay.
So I'm gonna do list add to end. In my case, arguably you could write this as a local function, but you could also argue that add to end is like a useful thing that other people might use.
Yeah, I think
So
it's no
yeah,
need to add that to a local function, yeah.
I'm going to do that. I'm gonna make it outside. So normally I'm gonna write tests and whatnot, but I'm just gonna skip the tests just for time. So pretend I wrote tests. Don't do this by the way. I
Okay.
want you to write tests in the future.
Okay.
So we apply the template, this template. Okay, so when it's empty, what do we do? Add to end. Oh wait, did I do the signature correct? Oh yeah. If we add to end to a num list that's empty, we just what do we do?
Like if the num list is empty,
Yeah, and we add a number to the end. What do we do?
mm, so it's num list of uh num and empty, yeah?
Okay, good, very good. Okay, yeah, it's testing you.
Okay.
Okay, and then in the the num list case, what do we do?
Mm,
Oh wait, I'm going to call this to add the parameter to
Okay.
add because it's
Okay.
naming
Yeah.
conflict. Oh crap. Yeah, yeah. So what do we do with the num in num list case?
Uh, we do like num list uh num list and to add, yeah.
Num list of what?
Uh of num list.
Num
Num
list of
list
num list?
like
There's two num lists? Sorry, actually, wait. You can write it. I forgot that we are sharing this session. Can you write out?
yeah of like num list like
Oh,
the
sorry. Okay,
name,
I
yeah, but we have like stupid names, yeah,
okay.
and to
Well,
add we we have to write this, or is that
well, num list is a list, right? We're trying to produce a list of numbers, right? So let's write the signature. So add to n, it takes in a number and num list, and it produces
mm,
a
right,
num list, right?
right?
But on line 409, you wrote num list, num list. That's a list of numbers. But that doesn't match the signature. We need a list of numbers.
Oh, okay.
Okay, let's undo what your changes. We will need a template, right?
Sorry, I can't I do because it's
Oh,
like we
wait,
are,
really? Okay,
yeah, we have like,
we share the undo history. Okay, I did not know
yeah,
that.
we share that, and
Uh, so
it's
this
quite
was the
funny.
template.
Yeah.
So notice like the code you wrote just now did not follow the template. So chances I was incorrect.
Okay.
Let's start with the numlist template. What should the template be?
Mm, like add to end.
Okay, let's do add to n. And remember, what does add to n take in?
Mm, okay, so it would be like, what is that like? Number and num list.
So what's the add to n takes in two things. First, the number to add. What's the number to add?
Like to add, yeah.
To add, good.
It's
Okay. How about the
yeah,
second argument? What's the list we're trying
like
to add to the
num
end of?
list, yeah.
Okay,
Or
so
okay.
remember what our template say. What was in the add to n?
Mm, okay. Or yeah, we need to have the num list here, yeah.
We need a number list, but what is the number list? Refer to the template. In the template, what should we put inside the call to the template?
Mm, where is it? Okay, so it's like rest, yeah. So
Yes, rest.
yeah.
Yeah. Okay, so here we have two pieces of things now. We have num and we have add to n to add rest. How do we bring them together?
We create a num list.
Good, good. Let's do that.
Yeah, but how to add it like at the end? This would add it to the end.
I mean, that's
No.
what the function says, right? It says,
Okay.
yeah, it says like, okay, here's the number to add. Let's do it to the end, to the rest of the list. And you trust that it works.
Okay. Okay.
Okay. So if we run this, hopefully all the tests should pass. Yep. Okay, I want to talk about something. I want to talk about what happens if we change line 409 rest to num list. What would happen here?
Mm,
Would it give an answer?
No, I don't think so because wait. uh, Can you explain it to me?
Oh no, let's just run it.
Okay,
Okay, I'm
okay.
gonna run it. Let's see what happens.
Yeah, it's running in a loop, yeah?
Oh, it doesn't end, right?
Yeah.
Okay. It will
Okay.
eventually run out of memory, but I'm just gonna stop it. So
Okay.
here's what's happening. When you make a recursive call to the same list, you will
Right.
get an infinite loop.
Yeah, because we are doing the same thing that we did in line 406, yeah?
Yes.
That makes sense, yeah.
Yeah, okay. So this is why we use the template. That's why the template says rest. You want to operate on the
Okay.
rest of the list. I also want to think about like how like the systematic way of approaching this. Notice how like when you try to like solve it in one go, you like sort of hard to think about it. But just now I gave you one thing at a time. Like, oh, first, what's the template function call? Oh, it's recursive. Okay. Okay, what's the arguments to that recursive call? Oh, it's to add and rest. Okay. We have num and add to n. What do we do with the two? Oh, we bring them together as a list. You saw that
Yeah.
thought process? Okay.
Yeah.
All right. So that's reverse. So this is actually the my intended solution, but it's actually worse than the one you gave me.
Really?
Because of performance reasons, we'll revisit this idea, but it's actually O of n squared. It's quadratic time. Yeah.
Yeah, it makes sense, yeah, because
Uh, yeah, because for each number, like, we have to reverse the
yeah,
list, right? And how many numbers are there? It's proportional to the length of the list, so it's O of n squared. The one you gave me is O of n, but it requires you to have a list that you're building up.
okay.
Okay, we'll revisit this idea in the future. It's important, but I'm going to give you more exercises now. Let's see. Okay, I wrote this down yesterday. Let me find them. Oh, I dropped my pen. Okay. Do you know what interleave means?
I have no idea.
Okay, so I'll give you, okay, usually I don't give examples, but this one I'll give you an example.
Okay.
So if you have like 1, 2, and like 3, 4,
Yeah.
it'll become 1, 3, 2, 4. It
Oh,
alternates
okay.
each number from each list and produces a new list.
Okay. Okay.
Okay, can you start working on that? I'm gonna start giving you new tasks as well.
Okay.
You can begin, by the way, for interleave.
Yeah, because like if I will write, we would like we
Will it
want
mess it
like
up? Okay.
I don't think like you can try write something.
Yeah.
Yeah. Okay. Okay. Sorry.
All good, all good.
I just didn't know this. Okay. So I am going to my template. Hmm. What is the template? Here. Okay.
Follow the design recipe. What should come before the template?
Yeah. Sorry. Sorry.
Actually, it's okay to paste in a template. I just keep it like you
Yeah.
can actually reshuffle the steps. Just keep in mind the design recipe. Yeah.
Okay. Uh, Okay. Mm, you have like you're saying empty. I will write cases like where examples for that. Mm, it's prepared. Oh,
Wait, list
yeah.
reverse should be interleave, right?
Oh, sorry. It's like sort. Yeah, sort.
No, no, interleave. Line 414.
Oh, it's interleave. Sorry.
Yeah.
I like. Oh, I just skipped one task.
Hmm.
Interleave. Mm, it will take. Can just do anomalies. Can I just copy like the task? It's like the same as
Yeah.
I think that it does. Yeah. Uh, mm, wait. I can I go like take a tea?
Sure.
Okay, thank you. Okay, I'm back.
Oh, welcome back.
Thank you. Uh, okay, so it's not list reverse, but uh, oh, we would need like another list.
No, we'll grab some water. I'll be right back.
Okay. Hmm, I can just write it like this. It will be easier. Uh, uh, I have like oh, 1, 1, 2. Okay, we don't need like third case. I don't have time. Uh, Okay, so if the first one is empty, like we would return the second one. Okay. Mm. And we
Nice.
have, and we need to have like I can write. mm, Can I just copy like this here? So in the first step, it will become like, okay, okay. Huh. It really does alternate. Yeah. So it must, yeah, we need to return a num list, of course. Hmm. It will be actually num and like the function name, of course. And it takes two things. And then we will start from the second list and do the rest of that one. Uh,
Cool.
well, maybe I'm missing. Yeah,
Yeah. Word of advice, use examples. Don't create a list in here because it's very hard to like match the parentheses.
okay. Yeah, I did something wrong. What is wrong here? What is wrong
Read the error message.
here? So the left side is missing something. Something.
Okay, I have to send you a new Zoom session. This one's gonna expire.
Yeah, of course.
All right, I'll see you in a minute.
Yeah, it was like problem with the parentheses. Yeah.
Congrats. But yeah, I do recommend like if you use examples just now, you wouldn't have had that problem, right?
Yeah, yeah. It was like,
Wow.
yeah, a lot easier.
Okay. All right. Let's move on to the next problem. Good work on this, by the way. It's actually pretty tough. You solve it very quick.
Okay, thank you. Uh, yeah, I need to copy the template again. Why is it so far away? Mm, okay. What is the second one? Sort again in given list of numbers. Okay. So num list, tab list. Uh, list sort. Mm, okay. Mm, Okay. So is it if it is empty, we return empty, of course. Uh, and when it is not, hmm. Do we need like a helper function for this? I'm pretty sure. Yeah,
Maybe.
maybe. You are not giving me any hints.
Nope.
That's unlucky. Uh, okay. So we have a num and the rest. Yeah. Mm, so we have to like, of course, compare two numbers and change the places if they are not in the ascending order. Yeah. But uh,
So don't think too hard. Did what we did just now, where we looked at num list template and we asked ourselves, okay, what should num list template be?
okay, okay. So it would be a helper function, yeah. Uh, okay, so okay. I might do like a function. Mm, okay, design recipe, of course. Mm, the idea is to like insert the mm, number into a okay to a num list. I will explain my idea. And we have a number and a sorted num list, right? And we need to like insert the number in the correct spot. Mm, okay. You are still saying nothing. That's what I like here.
I am watching.
Okay. That is
Okay. Before creating a new function, I rather that you use it first. Like write the signature and purpose statement, but then use it first before you fill in the body. Does that make
okay.
sense? Yeah.
Can you say that again? Sorry.
So yeah, like write the line 441, like finish that line,
Yeah.
and then change line 439, update the purpose statement for this function. But I
Okay.
would then want you to go back to line 453 to use that function. But don't worry about the body yet. Don't worry about finishing insert number.
Like
Yeah, keep going.
okay. Uh, is that like my spelling is right?
Yes, perfect.
Okay, okay. So if if it's empty, okay, okay. If the number is empty, what if the num list is, can I like write
Okay, so yeah, fill in the parameters
it
first.
would be uh
Okay, so
uh
before you finish insert number, I want you to go back to line 453 and use
yeah.
this function first. So pretend it works and does what it exact
Oh, oh,
yeah.
okay, okay. I understand you. Okay. Mm, so it would be who would use the helper function, of course. So in set number. Hmm.
Very
Oh,
nice.
dearest. Yeah, it makes sense. Yeah. So now we need to make the insert number function.
I do want you to
Okay.
write a test for insert number as well.
Okay, okay, of course. Uh, sorry, sorry. I got distracted. Like where? I just copied. Yeah, the num list of like mm, 5 and empty. Yeah, because
Cool.
yeah, that makes sense.
Mhm.
Yeah, okay. Mm, so set number of mm, 1. I guess mm, like oh, I missed one. Uh, okay. I think the test cases. Can I just leave two?
Sure.
Okay. Uh, okay. So if it's empty, we'll create a cardinal list of uh, and empty, and if it's not, hmm, okay. So we will need if statement, yeah. If it's smaller or equal to the compared num, yeah. It would be like a list of mm, set num and num list. As a list of like the num must be first and um, we must use the template because it's didn't I just copy now? Of uh, and yeah, uh,
Okay.
and this works, yeah.
Let's see. Let's see. Nice. You ran it?
Yeah,
Okay, we are running out of time, so I'm gonna start closing off. Okay, a few things I want to talk
okay,
about. They all have to do with testing. So I'm gonna do this. I'm gonna go to line 459 and I'm gonna do this. Okay, I'm gonna run. Ah, all tests pass. It works, right?
right,
You see what I did?
yeah,
So, rule
okay,
of thumb, never have only one test because you can make
okay.
the answer of that function to be the thing to make that one test pass. Um,
Hmm.
Second thing is for sorting functions specifically, there's actually a lot more interesting tests you can do. For example, what happens if you sort a list that's already sorted? What happens when you do that?
Hmm. We like do nothing, yeah.
So yeah, in mathematics we call
So
this the identity or idempotent. Get it?
okay, so we it's a waste of time, yeah.
To write the
Like
test.
no to sort the list that's already sorted.
Yeah, but I mean that happens sometimes.
Yeah,
There's also other test cases, right? When we have itemization data definition, so when there's one of many choices, what's when we test it, what do we have to do?
like use all the edge cases,
All the cases, right? So what's the
all the
case missing here
cases,
in list sort?
uh, empty list or
Okay. Yeah.
like you
So
called like a list that's already sorted.
yeah, so always like test each case. In this case, always test the empty, and it's like very quick, right? Takes
Okay,
like 5 seconds.
yeah,
Uh, then other interesting, always like increase the complexity of the test. So for example, like start with no numbers, then one, then two.
okay, okay, makes
Okay,
sense.
but sometimes like you're just trying to like be fast. I understand that, but other times I think it's good to practice being careful about how you create tests.
Okay,
I don't know if you plan to be a software engineer, but it will help you in that field.
maybe we
Cause
don't know, yeah,
you never know, right? Yeah, you gotta keep your options
yeah,
open. Cause yeah, like software, like it's very easy to write code, but it's also very easy to write code that's buggy, right? One
yeah,
or two things that's a little bit wrong, and everything falls apart in ways you don't know. Uh, so like the insert number also that also other interesting tests. For example, like what if numbers should be inserted in the middle or at the end, right?
right, yeah,
Yeah. Uh, testing is going to be something we'll continually revisit. Testing is also a reflection of your understanding of the problem.
Okay.
Yeah. Okay, yeah, so if you like for homework, you can continue the rest.
Okay.
I will say though the last two are quite difficult. It's going to
Okay.
talk about a list of numbers, and you have to do something that's a bit different from what you've usually been doing.
Okay. Okay.
All right, good luck.
Thank you.
All right,
Can I send you this if I manage to do that?
yeah, yeah, sure. I can like
Okay.
take a brief look, but I can't like look at it too deeply.
Okay. Yeah, yeah.
Okay. All right, well, we'll wrap it up here.
See you tomorrow.
All right,
Thank
I'll
you
see
for
you tomorrow,
today.
Simon. No problem.
Bye.